Now let's try to minimize this DFA. Okay, first of all, it is DFA because you can check it for every state, for every symbol. Here the input alphabet is 0, 1 and states are ABCDs, right? So this is a DFA for every state, and for every symbol there is a transition, and I have just written the transition table for the DFA. So before going ahead and then minimizing it, just see if all the states are reachable or not. B is reachable, right, and C is reachable, right, and D is reachable, and E is reachable. Yes, all the states are reachable. Fine. And what is the final state? Initial state is A and final state is E. So these are the final states. E is the final state. Okay, so let's write down the zero equivalence. Zero equivalence is set of non-final states and final states. Set of non-final states are A, B, C, D, and final state is E. And one equivalence is I'll see if any of these states can be written apart. Let us take A and B and C. If I see A and B, they are going to BC. BC is in one group, and D both are in different groups. Therefore, A and B have to be separated. Now let's take C, and C with what should I be writing it? A and C. Let us check A and C. A and C are going to BB. Yes, they are in the same group. DE. Again, DE are in different group. Therefore, A and C are not in same group. Let us compare B and C. If I see B and C on 0 are going to B and C are in same group, and E and E are in same group. Therefore, B and C are in same group. Now let us see if C and D are in same group. Let's compare C and D. Yes, if I compare C and D, now you can understand that C and D on 0 are going to B and C, they are in same group, and E and D, they are in same group. Therefore, D is in same group with C. Fine. So this is how one equivalence looks like. Now let us say two equivalent. How do I get two equivalent? I'll take one equivalent and then the transition. Now B and C. Let us compare B and C and see what happens. B and C on 0 are going to B and C. Yes, they are in same group. And E and D. Yes, they are in same group. E and D are in same group, which means the same state, right? So B and C are going to be in same group. And what about D? Let us compare C and D. C and D are going to B and C. B and C are in same group, and E and D, obviously it is just one state. Therefore, B, C, D are in same group. Fine. Now check these two. We have reached a state where the sets and the values are not changing over the equivalences. Therefore, we can stop here and say that we have three states in the final automata. So let's see how this final automata looks like. So it is nothing but they are saying that A is the initials, A is one state, B, C, D are in one state, which means they are saying that all the entire B, C, D are in one state. So it looks like this: A, B, C, D and E. We have only three states. A is one state, B, C, D are one state, and E is one state. Now small a on 0 or 1, it is going to B. Small a on 0 is going to B, which means on 0 I should take it to B, which will even contain B, C, D, right? And 1 it is going to D, so which means it is again B, C, D. See, if it is going to D, then make a transition to a state containing D. Okay, and B, so I will take small b and discuss. And small b on 0 is going to C, which means on 0 is going to C. Small b on 0 is going to C itself, which means you have to make a transition to the state containing C. And small b on 1 is going to E. 1 is going to E. This one is complete. Again, E is going to E itself, 0, 1, right? This is the final answer.